Okay, so let's talk about reproductive patterns. Okay, so species of organisms vary in number of births per reproduction cycle in the age that reproduction begins and in the lifespan of the organism. What does that mean? What does a reproductive pattern mean? There are two reproductive patterns. We have R strategy and then we have K strategy. Let's talk about R strategy. R strategists, short lifespan, and they produce many offspring. Okay, these are typically small organisms. Okay, as an adaptation for living in an environment where fluctuation of biotic and abiotic factors occur. So in other words, it fluctuates per season. Locusts, for example, they'll have a massive growth during the spring when their plants are lush and green, and then they die off shortly after. So locusts will reproduce by the billions. They'll consume their food, they'll do their thing, and then they die off. They have a very short lifespan. These are small organisms. Okay, mice, like we just talked about, it's a small organism. It has a short lifespan, and they produce many, many offspring. Now, again, it's lucky that they live short, because can you imagine if locusts or mice had a long lifespan? We'd be dealing with this infestation for generations on. So a lot of it has to do with the seasons. Okay, if it's a high season, then you'll have a high population. If it's a low season, then not so much. Now let's talk about K strategists. K strategists are generally larger organisms. They have a longer lifespan that's similar to that of a human, and sometimes even beyond that, and they produce few offspring. An example would be elephants. The lifespan of an elephant is about 80 years. They typically have about 6 babies in that lifespan, so about 1 per 20 years or so, and they only have 1. Orcas, same thing. They have a lifespan about 80 years in the wild. They have 1 calf every 3 to 10 years. So larger organisms with larger lifespans, but smaller offspring, or a smaller amount of offsprings that they do in a given reproduction cycle. Whereas mice will have hundreds of mice per reproduction cycle, and locusts as well. So human population growth. Now this is a graph that you've seen in your textbook. Okay, you've seen this in your textbook. So hopefully by now you do have an idea. I will post up the link to the video that we watched online that you can also view, so that you can get a better idea as to what this is saying. So this graph, this human population of the Earth graph, is just showing us how the human population has grown over the ages. And as you can see, from the Stone Age, Bronze Age, Iron Age, to the Middle Ages, we had a lag phase, and then in modern times we hit a huge exponential growth, and it's, as you can see, it's been stressing the Earth ever since. Some of the reasons why we hit this exponential growth has been because of technological advances that we've had. Genetically modified foods. We can grow more crops now, more pest resilient crops. So animals they're not as vulnerable to insects as previous crops were, and we can produce more now. Medicines keep us alive longer. So certain diseases that used to kind of control the population are now no longer a problem. We've also basically learned to manipulate our environment so that we can live anywhere. We are not limited by abiotic factors like other organisms are. So if our population gets super dense in one area, well, we can go ahead and move to another and populate that area. Now, but in general, even though we've hit an exponential growth, we're kind of now, if you're picturing your S curve, we're hitting that curve now on the upper S, where our population is kind of stabilizing. We're still growing exponentially, but it's not as much. We're starting to slow down a bit. So if you look at this graph here, we're still growing, okay, but you'll notice that there's a downward trend in this graph, but that downward trend is still a positive growth. So the human population is still growing. So around 1960, in the mid-1960s is when we hit our peak of 2.2% increase in the human population on Earth. And ever since then, we've been slowly kind of going down. Now, we've been going down for a number of reasons. Number one, our birth rates are going down. People are waiting longer to get married and they're having less kids. China, for example, one of the countries that has blown up with their population, and India, the Asian countries, they're introducing laws and they're introducing contraceptives and such, where they're encouraging their families to have less kids. Now, China is one of those that they actually had a law where you could only have one kid, but that created a whole slew of other issues that they're now dealing with. But in general, now people are becoming a little bit more aware of the stress that our massive population is causing on the earth. So, as a whole, as a planet, as a whole, we are trending downward in the number of children that we have, and our growth rate is slowly going down. Now, there have been certain events that have happened throughout history that have also impacted our population. For example, in the 1300s, we had the bubonic plague, where 75 million people died. We also had Thomas Malthus was the first to address this issue with an essay, and he discussed how this exponential growth in population is going to cause hunger problems, resource problems. So he was one of the first to address that issue. We had the Industrial Revolution in the 1800s that caused a huge spike in our population, and that was kind of the beginning of our exponential growth in our graph. Then we had the Spanish flu in the early 1900s, right a little bit after World War I, where millions of people died. In World War II, that was 50 to 80 million people died in World War II. That's about 3% of the world population. So you have these world events that occur that cause a dip in our growth. Now, even though the planet is in general going down as far as population, that doesn't mean every country is going down. So, for example, if you look at this graph, now this is not up-to-date statistics, but Afghanistan has a population growth of 4.77. And then you look at Kenya, Niger, they're going up in population also. But then you have areas like Bulgaria, Japan's not on here, but Japan is also experiencing a population decline. France, Europe as a whole is kind of either holding steady or going down. So you can see not every country is going down in population or going up in population, but as a whole, on average, the human race on the planet is going down in the rate of increase is slowing down anyways. Okay, so that was that graph that we were just looking at. You can take a look at that. Pause the video here if you wish. And then last but not least, we have our final graph. We have the age structure in human populations graph. This graph shows us the types of how our data pretty much looks with different types of growth patterns. So we have a rapid growth on the left, we have a slow growth in the middle, and then a negative growth on the right. Take a look at how these graphs look. The rapid growth has a pyramid structure to it, where if you look at the pre-reproductive age, you see the population there is actually much greater than the reproductive age. So what that means is that the reproductive age, the population in that age group in the reproductive age, that means that they're having a lot of children. That's why the population down below, it's bottom heavy. They have a lot of children, and then if you look at the post-reproductive age, kind of the the 40s all the way to your retirement and twilight years, the population is incredibly small. Now, this can mean a lot of things. It could be a lack of health. I mean, there's a lot of reasons why the elderly in this particular age group might be less. But in any case, this particular type of graph shows that the population in Kenya here is rapidly growing. And this is what it would look like. You typically have a lot of younger kids with a few reproductive and then even fewer post-reproductive. Now, what about a slow growth rate like the United States? Well, if you look at the reproductive, okay, that's actually the more numerous of the three groups. And then you have a pre-reproductive, which is around the same. Okay, so what that means is that the reproductive age group, the age group where you can have children, they're not having as many kids. So the growth rate is not as high. And then, of course, if you look at the post-reproductive, there again, they are the smaller of the three groups, just like rapid growth. So rapid growth and slow growth have post-reproductive as being the smallest, and it's the smallest by a fairly considerable amount compared to reproductive and pre-reproductive age. Okay, so that means the population is pretty much evened out for the most part. There's not a lot of growth and not a lot of death either. So look at the negative growth in Germany. The reproductive age group is about the same size as that of the US, but now look how many kids they're having. Pre-reproductive age population. They're not having nearly as many kids. They're probably having maybe half as many as the slow growth, and maybe a third to a quarter as much as the rapid growth. So you have a lot of adults not having a lot of kids, and then look at the post-reproductive age group. They're actually, almost right on with the reproductive age group. So there's a lot more older people, if you will, in Germany than younger. And if you look at Japan's graph, they're going to be around the same thing. Their post-reproductive population is large compared to their reproductive and even pre-reproductive. They're facing some pretty interesting challenges with people not even marrying anymore and not having kids. So some interesting challenges there in that particular country. Things that you'll need to be able to gather from looking at this data and understanding how this data is structured for age structure questions. So that does it for this video. I hope this helps. Good luck in your studying.